Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with, chapter 5, which is about measures of center of triangles. We talked about mid-segments and we talked about perpendicular bisectors and the circumcenter. Today we're talking about the angle bisectors and what's called the incenter of a triangle. So we have some more properties with angle bisectors that we'll learn about today. So let's name this lesson. 5.3 is use angle bisectors of triangles. Essential question is compare and contrast mid-segments, perpendicular bisectors, and angle bisectors. Okay, so we have a warm-up. It says the line BD is the perpendicular bisector of segment AC. Use the perpendicular bisector theorem to find AD. All right, so why don't you guys go ahead and pause the video and see if you can solve this. All right, so this one, if this is the perpendicular bisector right here, this right here, that means these are congruent. So if they're congruent, what are we going to do to them? We're going to set them equal. So 2x plus 20 equals 7x. All right, how do we solve for x now? Minus 2x. So we got 20 equals 5x. Divided by 5. And 4 equals x. All right, we done? What are we looking for? We're trying to find AD. What was AD? Well, AD was 7x. So we're going to plug in 4 for x. 7 times 4. So AD is going to equal what? 28. All right, sounds good. Okay, so let's talk about some definitions and some theorems here. The incenter, say incenter. The point of concurrency, say concurrency. Of the three angle bisectors, the three what? Angle bisectors of a triangle. All right. So here's the thing, all right? So the angle bisector, most of these kind of like properties of like perpendicular bisectors, angle bisectors, you're basically going to set stuff equal. You just got to figure out what's going to be equal, right? So in this case, if a point is on the angle bisector, this is the angle bisector right here because these angles are congruent, okay? What that means is that it is equidistant from the two rays of the angle, which means these are congruent right here, okay? So we're going to say DB is congruent to DC, and we're going to put rays right here, okay? So basically, yeah, for most of these kind of problems here, these properties are going to be equal, all right? And then the converse is also true. If these lengths are equal, that means that this is the angle bisector right here, okay? It's on the angle bisector, okay? And AD bisects angle BAC, all right? Sounds good. Okay, so let's go ahead and, do this here. So it says, use the angle bisector theorems, find the measure of angle CBE. Okay, well, we can see these are both 21 right here, right? Which means these are congruent, which means this has to be the angle bisector for that to be the case. So if this is 31 degrees, what would this angle have to be over here? It would be 31 degrees. So measure of angle CBE is going to equal 31 degrees. Ta-da! That's it. Okay? So you're either going to be solving for these or you're going to be solving for the angles down here, okay? All right, example 2. For what value of x does P lie in the angle bisector of J? All right, for this to be the case, for this to be the angle bisector, that means these have to be congruent. So what do we do with congruent things? Well, we set them equal. So we're going to do 2x minus 5 equals what? X plus 1. All right, let's solve for x now. Why don't you guys pause the video, see if you can solve for x. We're going to subtract x from both sides now. So 2x minus x is x. We have x minus 5 equals 1. Add 5. And we get x equals what? X equals 6. Are we done? Are we looking for anything else besides x? We are not. X is our final answer here. Okay? All right. This next one's a little bit tricky. Okay? It's going to use what's called the Pythagorean theorem. What do you guys know the Pythagorean theorem? Pythagorean theorem is a squared plus b squared equals c squared. It has to do with right triangles, okay? All right, so it says in the diagram, N is the incenter of triangle ABC. Find ND. I'm going to box that. We're looking for ND. Use a different color too, actually. Okay, we're looking for ND. We know that C is 20. We know that A is 16. And we're actually looking for this. But one thing about incenter we didn't really talk about is that all these lengths from the incenter, where the angle bisectors meet, to the edge at a right angle are all going to be congruent, okay? So we can call this X, but this is also X right here, okay? So what's the setup here? Well, we have this triangle. Let me draw that triangle like a little bit better so we can see it better. So we had X is right here, we had 20, and we had 16. How do we solve for X now? Well, we're going to do a squared plus b squared equals c squared. So in this case, we're going to do x squared plus 16 squared equals 20 squared. All right, let's simplify now. X squared, what's 16 squared equal to? 256. And 20 squared is what? 400. How do we solve for x squared now? Subtract 256. So we get x squared equals what? 144. How do we get rid of that square on the x? We're going to square root. So we get x equals, it'd be plus or minus 12. We're just going to put 12 because it's got to be a distance. So 12 is going to be our answer. So we get ND, which is what we were looking for. ND is also x, which equals 12. And there's our answer. Feel free to pause that and go back and look through it. But basically, yeah, if you're looking for these distances right here, you need to use Pythagorean theorem to solve that, okay? So that's mostly with incenter. With perpendicular bisectors, you do not need to do that, but for incenters, you're going to need to do that, okay? All right, we have some checkpoints here. Why don't you guys go ahead and see if you can do these checkpoints, and we'll go through them in a second. Okay, find the measure of angle GFJ, which is this angle right here. Well, these are congruent, which means that this is on the angle bisector right here. So if this is 42, what is measure of angle GFJ going to be? It's also going to be 42. 42 degrees. And there we go. All right, for what value of x does P lie in the bisector of angle A? So if this is the bisector, that means these have to be congruent. So what are we going to do? We're going to set them equal. So 8x minus 7 equals 5x plus 2. How do we solve for x now? Subtract 5x. So we get 3x minus 7 equals 2. Add 7. 3x equals what? 9. Divide by 3. X equals 3. Are we done? Yeah, we're just looking for x. Let's find the value of x. Okay, so x equals 3. We are done with this one. All right, and the last one is kind of a good one to talk about because this is probably the hardest one, which is the Pythagorean theorem stuff, okay? So we're looking for ND. We're looking for this. This is x. But we know that all three of these are all congruent, okay? So what do we know? C is 10. This is 10. A is 8. So what's the setup here going to be? We're going to do a squared plus b squared equals c squared. Okay, so, yeah, what do we do? Well, it's going to be x squared plus 8 squared. Remember, okay, if you're struggling with what c is going to be, c is always across from the right angle. That's the hypotenuse, okay? That's the only way you can mess up Pythagorean theorem is by picking the wrong c, okay? All right, so what is equals 10 squared? We're going to solve this. So we have 8 squared is 64. 10 squared is 100. Get x squared by itself by subtracting 64. We get x squared equals 100 minus 64 is 36. Square root x equals 6. So ND, which is also x, is going to equal 6. Should have found ND. All right. So yeah, the last ones are pretty tricky. Make sure you go back and rewatch those if you need to. But yeah, thank you for watching. Have a great day, and we will talk soon.